After the time zones and daylight savings detour, let us get back on path and explore another important aspect, date and time formats. Now, although it's a good practice to adhere to the ISO 8601 standard for representing date and time, not all data will comply with it. In real world, date and time may come in all types of weird formats. For example, the date 12th December 2019 can be written in all the below formats, right? So December 12th 2019, 12th December 2019, December 12th 19, the year is specified only as 19, and then you have 12-December-19, right? 12 December 2019. So all these different ways in which that particular date can be written. Now, when the data is not in the ISO 8601 standard, we need to explicitly specify the format in R. Now, we do this using conversion specifications, right? A conversion specification is introduced by percentage symbol, usually followed by a single letter or O or E, that is capital O or capital E, and then a single letter. Now, there are lots of different conversion specifications, but we'll explore the most important ones, or the ones that you will tend to use regularly, right? So for example, the day of the month is represented by percentage D. The month, when it is in the decimal format, is represented by percentage M. The month in its abbreviated format is represented by percentage small letter b. When the month is specified in full name, then it is represented by percentage capital B. If the year is represented only by the last two digits, it is specified using percentage small letter y. When all the four digits of the year are specified, then use percentage capital letter Y. The hour, minute and second are represented by percentage followed by capital H, M and S respectively, right? So these are the important conversion specifications. There are lots of others, right? We have added links for them, you can go through those. But when you start dealing with date and time data, these are the ones that you will most frequently use, right? And it's good to start with this, right? These are like the simpler ones and the basic building blocks, right? So once you have understood this, you can look at more complex conversion specifications as you start dealing with more complex date and time formats. All right, time to work through a few examples, right? So now let us say we are dealing with the date that we have looked so far, that is the release date of R3.6.2, which is 12 December 2019 in a particular format. Okay, so I will add that here. First it is date/time formats. Okay, let us say the date is in this format, right? Year followed by month followed by day. Okay, now we have to figure out a way to specify this using the conversion specifications. Okay, now let us start looking at this date properly, right? So they are separated by a slash, and the year comes first followed by the month and the date. Since the month and date have the same number, that's December is represented by 12 and the date is 12, it can be a little confusing, but this is the format we are going to specify, right? Year followed by month followed by date. Now if you look at it carefully, the year is represented only by two digits. That's the last two digits of the year. Instead of 2019, it is written as 19. The month is represented using a number, not using the full name or an abbreviation. And then we have the date, right? So now we'll specify this date using the conversion specification. And since we are dealing only with the date component and not with the time component, we'll use the date class, right? So let us start with as dot date, right? And then we specify this date in the format in which we have it right now, and then we'll use the format argument to specify the conversion specification, right? So if you go to this slide here, we know that when the year is represented in 2 digits, we have to use percentage followed by the small letter y, right? So we have year first, so we'll use this, followed by the slash. Then we have the month, right? So when the month is represented by a decimal number, we use percentage followed by small letter m, right? So we specify that here, and followed by the slash, because that is what is separating the year from the month and month from the date. And the date is represented by percentage d. Right? So the 12th day of the 12th month of the year 2019, right? So now we have used the conversion specification to specify the format of this date. Let us run this. Right, now you can see it has come to the ISO 8601 standard format, right? The year followed by the month followed by the day, and the year is in 4 digits, right? So this is a basic example. When you have date in a different format, get it into the ISO 8601 format. Now another way in which the same date can be written is this, right? Let us say 2019 December 12th. Now let us try to use the conversion specification to format this date, right? We still have the year followed by the month and the date, but there are a few changes here compared to the previous example. The components are separated by a dash instead of a slash. The year has 4 digits, that is, it includes the century. In the previous case, it had only the 2 digits. And the month is specified using abbreviation instead of digits, right? The month is not specified in its full form, it's specified in an abbreviated form, and it is used instead of the digits as we saw in the previous example. Now let us again use as.date. Again, because we do not have the time component, we will stick to using as the date class. First we'll specify the date in the format in which we have it, and now we'll specify the conversion specification using the format argument, right? So let's go back to the slide. When the year has 4 digits, you use percentage followed by capital letter Y to represent the year. Now in the previous case, the year, the month and the date or the day were separated by a slash, right? But in this case it is separated by a dash instead of a slash. So we'll change this to a dash, and then we have the month in the abbreviated form, so it should be percentage followed by small letter b, and as usual the date percentage d, right? So see, again the date now is in the ISO 8601 standard format, right? The year followed by the month and the day, but the year is in the 4 digit and the month is represented by a number, and then you have the day. Now in both the above examples we have not dealt with time components, right? Both of them just had the date component. Now let us include the time of the R3.6.2 release in this next example, right? So it will include the time as well. So this would be 19/12/12, then 08/05/03. Right, now we know the format conversion specifications for the first part, that is the date component, right? That is what we did here. Now for the time component, we can see that hour is represented by percentage capital letter H, the minute is represented by percentage capital letter M, and second is represented by percentage followed by capital letter S. Now we'll add this to this example that we have here, right? Let us copy it. To this we have to add the time components, right? But since we are having the time component as well, we cannot use as.date. So we'll change this to as.POSIXCT, right? Because we also have the time component along with the date component. Next, here we have to specify the full format in which we have the date and the time, right? So add the time component here, and then you have the format, right? So here we already have the date component format, that is conversion specification for the date component. Now we add the conversion specification for the time component, right? So let us try and run this. Okay, so we have the date, then we have the time, and the time zone, it gives the Indian Standard Time. And this used to happen even in the second module when we were creating the date and time, right? Remember, even in the second module when we used as.POSIXCT, we ended up with the Indian Standard Time for the time zone. But the actual time zone is UTC, right? It is not the Indian Standard Time. The time at which the R release happened, it is in UTC time zone. So we need to add the time zone here as well, right? Because this time zone is wrong. Now let us see if we can do this here, right? So I'll just add UTC here, see what happens. Okay, so it returns NA, which means the format in which we have specified the conversion specification now is wrong. Time zone can't go there. So what do we do? Now when you're using as.POSIXCT, if you want to specify the time zone, can use the TZ argument and you can specify the time zone, right? Now you see it is in the correct format, right? The date and time component were already correct. The only problem was the time zone. We had the Indian Standard Time. Now it has changed and it has become UTC, right? So when you're dealing with date and time component, use as.POSIXCT or as.POSIXLT, depending on how you plan to use the date data or the time data. Then specify the conversion specification using the format argument, and the time zone has to be specified separately using the TZ argument, right? So great. Now we'll take a look at some more examples. Right, now we have included a lot of practice questions for you to explore the different DateTime formats. All of them are there in the learning management system. The practice questions are there in the PDF, and the solutions in the format of Rsquared are also there. Now before we end this module, I want to introduce you to another function from lubridate, which is guess_formats, right? So the name itself makes clear what it does. It will guess the format for the dates that you have specified, right? It's a very useful function. It will guess the date time format if you specify the order in which year, month, date, hour, minute and second appear, right? You have to specify whether the year comes first or the month comes first or the date comes first. Only then it will try to guess the formats, right? So I'll try to create this release date in different formats, okay? And then what we'll do is we'll try to use guess_formats to guess the formats in which this particular date appears. So let us try this, right? This is the first format, but 12th 2019, and then we have December 12th 19. Sorry, I need to fix this here. Okay, and the last example is December 12, 2019. Okay, so now it's the same date but written in different ways. Now we'll use the guess underscore formats function from the lubridate package. This is the input, thus the date written in different formats. I made a spelling mistake here, let me fix it. Formats. Okay, and then we specify the order in which the month, date, year, hour, minute, second appear here. So since we don't have the time component, we'll specify the order, right? So in all the cases, the month comes first, followed by the day or the date, followed by the year, right? And then so have this argument print underscore matches, that is print those which match, right? Let's look at this. Let us look at the output from here. I'll clean this up here and let us look at the output. Right, so here you can see, right, month, percentage, D for the date, and since it has TH along with it, so you have that. Then the year, so the year is specified whenever there are 4 digits in the year, it uses percentage followed by capital Y. There's only 2 digits, percentage Y. It's guessing all the different formats in which these dates appear, right? And then you can use this to sort of narrow down the correct choice and then use it as the conversion specification, right? So if you're dealing with something that is really complex, right, some format in which the date or time has been written, and if it is very complex, the best thing to do would be to use guess underscore formats and then pick from that and use that as the conversion specification. Okay, now we have added a lot of practice questions for you. You can see them here. You can pick this out from the learning management system. The practice questions are in a PDF file and the solutions are in a R script. So try them, refer to the table, right? Refer to the table you have in the slides and the ones which are provided in the reference and reading links that we have given, and then break this, right? Break this, match them to the representation given in the table, right? Here, match each component first and then see how they are separated, right? In some cases it is a dot, in some cases it is a slash, and in some cases it is a dash, right? So choose that, choose the right separator, and then try to read these dates and then compare your solutions with the ones that we have given, right? So this is an important module. Do not skip this, go through this, spend some time on this. While we were initially discussing the case study, I had told that we'll be reading 2 other data sets which include date and time columns, and then I'll show you how to read them using the RStudio IDE as well as by writing code, right? So now that we have understood the conversion specifications and how to pass date and time, this would be a good time to try and read those data sets, right? So the first one is receivables.csv. This is similar to transact.csv, and this data set is also there in the learning management system. Please download it before you try to read this in. Now it has a lot of columns, but we don't need all of them, right? So we need the invoice number column, the invoice date, due date, and the settled date. These are the only columns that we want to read in, right? And what we'll do is, in this case, we will write the code to read in the data set, and then there is another data set which is HR data. In that one, then there is another data set which is HR data, and we'll read it using the RStudio user interface. Okay, so let us read this data set in. First you need the readr package, right? and then you can do it as read underscore CSV. The name of the file is receivables CSV, and then we'll say, since we are not reading all the columns, we'll use call underscore types and then calls underscore only, right, to specify those columns that we are going to read in, right? So the first one is invoice underscore number, this would be call underscore double, and then we have invoice underscore date, which will now be call underscore, since we have only date component, we do not have the time component here, we can use call underscore date. When you have the time component, you can use call underscore date time, right? Once you do this, you have to specify the format, right? And this is where the conversion specifications come in. So here we have the month followed by the day and then the year in 4 digits, right? So this would be %m / %d / %y, right? This is the format in which this column is there, and other 2 columns as well, they are in the same format, right? Whether it is due date or settled date, both of them are in the same format. So you can just change the column name here, right? And now we'll see if this works or if you have made any mistake here, right? So it works, right? So it has read in the data set, it is displaying the first 10 rows for you, and then here you can see the column data types as well. First one is double, and then all the 3 are of type date, right? That's what we did when we were reading in this data set, right? So this solution is also there in the learning management system. You can access the code. I would suggest that you try it, and then if you're getting any errors, then you can refer to the solution that we have provided, right? So this is reading the data using the code. What we'll do is, now we'll look at the second data set, which is HR data, and then we'll use the RStudio IDE to read it in, right? So in RStudio, you can go to File and then come to Import Data Set. Here select From Text Reader, right? So we are reading in a CSV file, so you can select this, okay, and here we have to select the file. So click on Browse and then select the data set, which is hrdata.csv, right? So it will show you a preview of the data set here, and here you can also see the code being generated as we read in, right? So as you read in, the code will be generated, so you can copy paste that code and use it some other time as well, right? So here we have the data set, right? And let us look at the columns that we need, right? So we need the employee name, okay, and we need 2 other columns, right? So the date of joining and the date on which they were terminated. So here it is date of hire and date of termination, right? So here we can select the columns, right? So this would be character, and then you can skip this, or here we'll specify only as well, okay? So that is taken care of, and since we want to skip all of this, instead of going on skipping each of them, we'll only select those which we need, right? So date of hire, make it only, date of termination here, and here we'll change the data type. So this is date, right? Let us look at the Okay, so date of hire, so it is month, day and year in 4 digits, right? So we'll specify that here, month, day and year in 4 digits. Okay, and then we'll again change date of termination. Okay, so once it previews the data again, we can change the next column. Okay, now you can see date of hire has become date. It was character earlier, right? Now we'll change date of termination, but here you have to remember that here it is month, day and the year is just in 2 digits. It's not in 4 digits. Okay, like here it is in 4 digits, but here it's only in 2 digits. So if we go here, this we'll have to change to small y, because the year doesn't include the century, right? It doesn't include 4 digits, it includes only 2 digits. So from capital letter Y we go to small letter y. Okay, so here you can see the code has been generated, right? It's similar to what we have here, right? If I copy this, you can see that it is similar to what we have here when we read the receivables data set, right? So now what I'll do is I will import this data set, okay, and then we'll look at the code, right? Great, so here you can see the data set has been imported, right? You have the employee name, date of hire and date of termination. Let me call it here as well, HR_data, so that you can see the column types. So employee name is character, date of hire and date of termination are of class date, right? And we have clearly passed it. Now let us compare the code, right? So so if you can see the code here, the same, right? read_csv, then we have the name of the data set, then call types, right? And since we are reading only a subset of the columns, we use calls only, saying that only these columns must be read, followed by the name of the column and the data type. So here again we have used call_date, we specified the format. Only in this case, here all of them had the same format, right? Month followed by day followed by year in 4 digits, but here one column had month followed by day followed by year in 4 digits, which was date of hire, but date of termination was slightly different, right? The month followed by day followed by year in only 2 digits. It did not have the century, that is, it was not, instead of 2019 or 2020, it was 20 or 19, right? So depending on how comfortable you are, you can either choose to write the code yourself or use RStudio user interface, and you can read in the data. It will also generate the code for you. You can always copy and keep it, so that next time when you're reading this data, you can just paste that code and run it, right? So if you have any confusion regarding reading data into R, we have 2 courses on importing data into R. The one covers CSV and other delimited files, and the second one covers Excel spreadsheets and data sets from other statistical softwares like SAS, SPSS and Stata. So you can take a look at those courses, and you will clearly learn how to read or import data into R. And once you're done this, then we can move on to the next module, where we'll learn to parse date and time, right? So we'll look at more functions that can be used to parse date and time when they are available in different data types.
I hope you have enjoyed listening to this video. Please be kind enough to like, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos on our playlist, and subscribe to Rsquared Academy channel to learn more. Happy learning!